The world's climate is changing. Sea levels are rising. Storms are occurring with more rain more often. These changes make it harder for communities to address flood risk. In northern New Jersey near MetLife Stadium is a large low-lying area of New Jersey known as the Meadowlands. Like many other communities, it struggles to stay dry. Flooding from hurricanes, nor'easters, and inland storms caused damage in the area. After the destruction of Hurricane Sandy in 2012, the U.S. Department of Housing and Urban Development started a program to provide resilient solutions in flood-prone areas. The Rebuild by Design Meadowlands project is one part of this program. Overseen by the New Jersey Department of Environmental Protection, it focuses on a 5,000-acre area on the Hackensack River. Historically wetland, the Meadowlands is relatively flat and low-lying, with a rich and diverse ecological community layered within dense urban development. Stormwater infrastructure here is often aging, undersized, and underperforming. Streams and ditches are clogged with accumulated sediment and debris. In a multi-year process, the community, DEP, design team, and various state, federal, and local agencies work together to identify, prioritize, and design solutions to the challenges facing the Rebuild by Design Meadowlands project area. Local knowledge was invaluable in the process as the design team assessed site-specific conditions and potential solutions. The scale and complexity of the challenges of resiliency and urban water management in low-lying areas are extensive. As part of the conceptual design phase, the team selected a plan to address frequent inland flooding. This approach provided the greatest feasible benefits within the project budget. Although the Rebuild by Design Meadowlands project cannot solve every challenge, the final design phase focuses on building greater capacity by, quote, unplugging the bathtub and allowing more water to move more efficiently through the project area. The project final design is a comprehensive, multi-benefit watershed strategy. It is one piece of a larger network of projects needed to fully create a resilient region. The final design seeks to achieve three primary goals: to reduce flood risk by managing water flows, to cultivate ecology with native planting, and if funding allows, to energize the community through new public area improvements. Using a watershed strategy, the team designed improvements at multiple scales to meet these goals. A watershed is an area that drains to a common waterway. On a single piece of land, rain running off buildings and yards can be considered a small site-scale watershed. As the watershed flows and combines with nearby runoff, it becomes part of a neighborhood watershed. Then, continuing its course into a larger drainage network, the water flows into a waterway, such as a river, which then flows downstream, becoming part of a larger watershed. Understanding the watershed system, the team created a network of strategies that each improved the area's water management in different ways. At public buildings and roadways, sites are designed to absorb and filter rainwater. This improves water quality and biodiversity while lessening the burden on existing drainage networks. The design of parks and open space capture, store, and filter runoff while providing community recreation and ecological benefits. Large-scale infrastructure, such as pump stations, force mains, or pressurized stormwater pipes, and channel improvements, collect the largest amount of runoff and move it quickly out of the area to reduce flood risk. This strategy was applied where feasible within the project watersheds. By focusing on the drainage that most impacted low to moderate income residents and existing businesses, the design includes large infrastructure focused in the lower reaches of the watershed, and ecological and community amenities distributed within the area. The project addresses flooding impacts by getting water out of the area faster, therefore allowing businesses and low-income residents to return to normal operations faster. In the East Riser Ditch watershed, improvements focus on the lower reach or end of the channel. The channel is relatively shallow, and it often overtops infrequent storms. Channel improvements create more capacity for the rainwater to drain out of the area, and during storms, a new pump station moves even more water out of the channel. By deepening and widening the channel, water conveyance or flow is improved. The pump station helps control the volume of rainwater in the channel, and habitat is enhanced by planting native plants along the banks where feasible. In the Losen-Sloat watershed, there is an existing bottleneck in the drainage flow. This is alleviated with additional infrastructure that allows more rainwater to flow out of the area faster. A new pump station at Liberty Street pulls water out of the existing pipe and through a new force main, or pressurized stormwater pipe, that then discharges into an open area downstream. The pump station controls the volume of water flow, and the new force main provides more flow capacity. At the pump station, an on-site biofilter basin removes sediment from the parking lot runoff with the help of native plants. Along the Hackensack River, a new public park was designed based on community input. The design seeks to create public access on the river, provide community event space, improve biodiversity, provide environmental education, restore the shoreline with tidal marsh, and provide an accessible kayak launch and gathering areas. Native plants filter runoff. Park design provides placemaking, and wetland plants transform the shoreline. The team looked for opportunities to improve the landscape performance of public buildings and public roadways. Typical challenges at public buildings include on-site ponding after rain events, large impervious parking lots, and roofs with unfiltered runoff. To address these challenges, 4 strategies are proposed to collect and filter runoff before releasing it back into the drainage network. These include downspout planters, biofilter basins, permeable pavers, and simple site grading with new deep-rooted native vegetation. These each improve water quality and ecological habitat. These strategies are proposed at 4 locations based on site conditions and community needs: Joseph Street Park, Memorial Middle School, Little Ferry Borough Hall, and Little Ferry Public Library. Public roadways throughout the project area were also considered for green infrastructure type improvements. These improvements filter road runoff before directing it back into the storm system. They include biofilter planters, subsurface storage, and a bioretention basin. These are proposed in 10 locations. Although individually small, these features collectively lessen the burden on the storm infrastructure and improve the ecology and community quality of life. Designs such as this bring wide-ranging benefits to an area. By designing for flood risk reduction, rainwater will move quicker out of the area. There will be reduced flood damage, fewer business interruptions, and fewer street closures. Designing for ecological enhancements can result in improved water quality and reduced urban heat island effect. Designing for public realm improvements can result in increased recreation and improved quality of life. These are just a few of the benefits of the designed project. DEP will construct the large infrastructure such as pump stations, a force main, and channel improvements first to focus on reducing flood risk and allowing for quicker recovery after storm events. Designed to accommodate long-term operations and maintenance, this will build future drainage capacity in the area, making it better prepared for a changing climate. The team will construct the neighborhood and site-scale improvements as funding allows. Through a community-based process, the project has increased awareness of resiliency and water management in the region. New partnerships between state and local communities have been formed, which can assist in future resiliency. This project is innovative for its regional approach, spanning multiple municipalities which may not have otherwise been able to tackle these challenges alone. Only by working regionally with federal, state, and affected towns are these watershed improvements possible. The New Jersey Department of Environmental Protection has resources to support communities working together to tackle climate change. These resources seek to empower and engage community leadership to steward resilient solutions throughout the state and are part of New Jersey's strategy to achieve climate change resilience. Rebuilt by Design Meadowlands is just one piece of a larger network of projects needed to address the complex environmental challenges ahead. The designed project is a scalable, regional approach with replicable strategies for other watersheds in New Jersey and elsewhere. This project is one of many that strengthen New Jersey for today's climate threats.